Welcome back to the house that my family has been building for the last 2 years. We are in the finishing stages and we are finally using the house. And what I'd like to talk to you about right now is one of the systems that is incredibly important for the house, mostly invisible, although you can see some of this stuff from the living space, which is fun. We have 5 machines that I'm going to show you right now. There are a bunch of different things that we could talk about with hot water systems, and I'm not going to talk about all of them, but the most important thing to me is the machinery that we're going to be using to deliver hot water to the fixtures that we've got, like sinks, bathtubs, showers. You need this in your house. Right now, Texas is completely frozen up, and we will probably be installing a lot of new water heaters because people have things like tankless water heaters installed outside their house. Tankless water heaters are cool. You have seen other videos about those on this channel. They're not necessarily all that the hype is talking about, just like solar, just like spray foam, but they are very useful machines, and in the right application, they're brilliant. So we have 5 Chronomite point of use water heaters, which is different than tankless for a couple different reasons that I'll get into. But these point of use machines are small. They do require electricity to run, which means that now our house is completely electric, which I am not obsessed with. Not everybody's house needs to be totally electric. That's important to say. But for us, we found that it was the right thing with how airtight our house is, with all of the other components that are in the house, the fact that we would only use gas on the stove, and now we have an induction cooktop, which I'm going to show you soon. So this electrical controller thing, especially with microprocessors involved, gets really sophisticated, and that's why I wanted to show you these Chronomite systems and exactly how they work. By the way, these are great little machines, and we're going to talk about, how they just plug right in. But just like any other machine that you're going to see used in the science of homes on this channel, on the Home Diagnosis television show, they need to be tuned to the particular scenario that they're in. And if you stay tuned to the end, I will show you a fascinating example of how you just plug a machine in, and it might not do exactly what you want it to do, but if you tweak it, if you tune it a little bit, then you will find that it can do exactly what you want. That's why you really need to educate yourself, why you need to have professionals in your area that are well-trained and are able to ask questions and able to think, maybe I don't know everything. Read into the manuals, call the support lines, things like that. By the way, this video was inspired by a YouTube viewer who commented saying that I didn't know what I was talking about with tankless systems on a video from a long time ago. And we got into a little discussion in the comment thread. It has since been deleted. I think that person maybe was embarrassed by the fact that they told me that I didn't know what I was talking about, but it was very important for me, and it actually inspired us to look into the point of use systems. You may have never seen a system like what I'm about to show you. If you go to Europe or Asia, they have a lot more of this stuff. But here, I think that you might see more of it because it solves some very interesting problems, which I was very happy to have solved, having run myself all of the water lines in the house, which was really fun. That's actually one of my favorite parts of this build. While 3 of the water heaters are in the crawl space, which again is basically a half basement, I'll show you that in a minute, 2 of them are mounted in the cabinets of the bathrooms where they are needed, one of which only because I could have put it in the crawl space, but it was nice to have it in the cabinet. That's in the powder room downstairs. It's the tiniest unit. It's only heating the half-gallon per minute faucet that's right above it. And in this case, in our kids' bathroom, we're up on the 2nd floor. So it wouldn't be a point of use water heater anymore if I mounted it 20 feet below us. That would be going back in time to when water heaters were nowhere near where we're going to use them. That's not a great idea. So we actually mounted this one right inside this beautiful cabinet that my dad built. So this is how I mounted the units in the crawl space. As you can see, we've got 1 disconnect, which is brilliant. This is 3 separate 240 volt circuits at 40 amps apiece. So this is 120 amps of power in here. I'm going to turn that off before I take this cover off. There are screws that hold this cover on, but I took them out beforehand so that it makes this a little faster. So this is the guts of the Chronomite system, is that we've got the main or master heater, and then we've got 2 supplemental heaters. This is all kind of, they're chained together. So each one has its own circuit, and when we run the water, the master will be the first one to turn on at that low flow activation, which is 0.4 gallons per minute. And then the second one turns on and the third one turns on as needed. What's cool about this is a couple of different things. It's got a microprocessor that controls the temperature. So if you were to pump a certain amount of cold water, and again, it needs to hit that low flow threshold of 0.4 gallons per minute, it'll kick on. And then if you were to kick on another fixture on the same line, the microprocessor will see the temperature of the outgoing water and will kick up so that it maintains the same temperature regardless of what the flow is. So that's what the microprocessor is for. The other thing about this is that it's very low maintenance. So because you've got water coming in and it's very aggressively banging up against all the walls of this heat exchanger and then going out, there's no place for it to hang out and form deposits. So it's self-cleaning because it takes a path. It's always flowing. And I won't have to be cleaning anodes and trying to maintain the corrosion resistance of the inside of this thing. Obviously, every machine requires maintenance. You do want to take that seriously, but this one is going to be as low maintenance as you could possibly get. This is also a really important feature on these, controllability. This is my dial to be able to increase or decrease the temperature of the unit as it runs. I just use a simple screwdriver and I can field adjust exactly what I want the unit to do. One of my favorite things about the Chronomite units that we got is that they have a very low flow activation. What happens when you have an instantaneous water heater, which be very careful about that word. We have truly instantaneous water heaters. They are point of use, and I will demonstrate that to you in a minute here. If I was to turn on cold water right here, and then I just want a little bit of warm water, a mix. If I just put in 0.35 gallons per minute of water flowing through my instantaneous water heater, then I will get a little bit of hot water flowing through the system. If it's less than 0.35 or 0.4 for all of the units that we've got, then it won't activate. And that's important for you to understand that some of the bigger units that you'd get, especially like a full tankless whole house system, are going to have a low flow activation of something much higher than that, half a gallon a minute or higher. So that means that if you have a half gallon a minute sink, it might not actually make your water heater turn on. So what you want to do is make sure that you're getting hot water within a reasonable amount of time. That is, I'm going to talk more about water efficiency in a few minutes. And also, I want my wife to be comfortable. So when she turns on the shower, I don't want her to have to then walk away and do other things for 5 whole minutes, which is a typical thing in America. Why? So I'm going to show you the temperature that we're getting out of the tub. We're starting from cold. This has not run hot water yet today. That means that every bit of the water in the hot water pipe, which is a 1/2 inch diameter that runs between this and the water heater, is at room temperature, 70 degrees. So you can see it's already kicked on. We're at 80, 90 degrees. Oh, no, went back down. Okay, there we go. Now we're jacking up. We're at 18 seconds. Just past 100 degrees, 23 seconds. And we're at 107 degrees, 108. It may go up to 110 based on how I have tuned this. And that was about 35 seconds to get to full, hot, 110 degree water. 112 degrees is basically as hot as you would ever want to go. That's where you stop having the benefit of the cleaning ability of the hot water and you start getting into, I'm hurting my skin, I'm hurting myself. 120 degrees is the standard, the like midpoint, set point on your typical tank water heater. The reason that it's 120 degrees is not because you want 120 degree water. You do not. Trust me, if it touches your skin, you're going to be in big trouble. The reason that it's there is because they expect for the water temperature to drop at least 10 to 15 degrees by the time it gets to your fixture where you're going to use it. That is kind of crazy if you think about it. Somebody is going to comment below that you need it to be 120 degrees to kill Legionnaires because you don't want to get sick from your water being lukewarm. This is a tankless system. What happens in the Legionnaires situation is that you've got bacteria growing in a basin, which is where you're storing your hot water. Here, we have the water taking one specific path and not hanging out in any one place. So there's no place for the water to pool and just kind of fester. That's an important difference. What we're getting here is hot water. It's delivered at least twice as fast as I would ever require anybody to be as a commissioning agent and as a consultant who's out there testing multifamily buildings and construction for other people. So 30 seconds is like pretty fast for super hot water, especially from cold start. And we're getting exactly the right temperature. This is what you want. While I'm at the tub, I want to talk about tub efficiency, because of course the efficiency of these Chronomite water heaters is great, but if you don't put them into something that is going to hang on to that hot water, then you're just going to have to, in the example of a bathtub, add up more hot water later on. You're going to have to like top it off, right? Which is what happens when you want to stay in the bathtub a little bit longer, but it's starting to get cold in here. These don't have that problem for two reasons. Number one, don't put bathtubs on exterior walls. Got it? Okay. Next, if you want your bathtub to actually hang on to water temperature, you want to make this either a very heavy material, which is what you'd get if you get like a cast iron tub or like a tub made out of solid rock. Great, good for you. Well, I don't want to do that. I don't want to have to structurally engineer my house to contain a solid rock tub, and I don't want to have to pay for something that's really, really expensive. No offense, I've spent lots of money on lots of other things in this house, but this was one thing that I was like, we could get that with another way to do it, which is, this is an acrylic tub, which doesn't have a lot of thermal mass to it, which means it's not going to hang on to the temperature very well. But what you're going to add to the hollow body of this is insulation. So we stuffed this full of rock wool insulation. We had a bunch left over from insulating the walls on the outside and on the inside of the wall structure and the ceiling. And so every bit of this is filled with that really high quality insulation. And then we just basically put a panel on the bottom to make sure it didn't fall out. And we're done. We've used it several times, and you could be in here for literally an hour and 15 minutes solid, and it's very comfortable. This is apparently an option that you can get as an upgrade on tubs now, but I would caution you, because probably what they would use in that case is spray foam insulation or some kind of a a curing, self-rising foam. And this house is foam free for a bunch of reasons that I'm not going to get into right now because I don't want to start a fight. But spray foam has, for just one reason, toxic flame retardants in it in the United States of America. I don't want those in my house because I've got kids. On the topic of other weird tweaks to your water efficiency is the toilet, which has nothing to do with hot water, and the ventilation system, which has even less to do with hot water. But check this out. If we put the exhaust vent for my toilet room right there, then it means that air is exhausted out through that, which it is. You'll see that in the ventilation video, which is coming up. Stay tuned. And replacement air comes in under the door, grabs whatever odors are around the toilet on its way out there. A lot of people will put that exhaust fan in the ceiling, which means that the air comes in and any odors that are hanging out around the toilet go all the way up through the room before exhausting out through the ceiling, which is a crazy way to do it. What this means, when you really think about it, is that we are allowed now to do a thing that I always thought was kind of gross, which is if it's yellow, let it mellow. I don't have to flush the toilet every single time I urinate. Any odors that would be hanging out and make your bathroom smell like pee are now being taken care of. This room will not smell like pee, even if you flush it half the time. With one of these that's over a gallon per flush, that means that you're saving water, which is always a good thing, especially when it costs so much. And where we are, water is pretty expensive. Partly, this Chronomite system is a really interesting experiment in plumbing material efficiency. You'll see a lot more blue pipes, which are the cold water lines, than red pipes, because I only had to run cold through the house. One pipe serves every zone. And then as soon as we hit the water heaters, then we switch over to both blue and red. You can see also I'm experimenting with insulated and uninsulated hot water pipes. The coolest thing would be, of course, that we heat water inside of this, and then it gets distributed through insulated pipes and none of the heat escapes. But I'm also, as you know, I try to be a very reasonable person. So when I'm installing in walls where I won't be able to get at stuff again in the future, I did insulate all of that because I wouldn't ever be able to make up my mind later to do it. But some of these are uninsulated right now, and I will be experimenting with that later because it might not matter. Everything might matter some, but for the amount of work and time and energy and money that you put into something, it should really give you a big payoff. One of the interesting problems with modern plumbing is that the plumbing pipe sizes minimum are mandated by code. So we have to have 3/4 inch diameter pipe going to all of the zones. And then from there you can feed individual faucets and toilets and things like that with a 1/2 inch pipe. But that means that when we have low flow fixtures, like low flow toilets, water efficient faucets and showers and things like that, that you're moving very little of the water inside of that 3/4 inch diameter pipe. This is a conditioned crawl space. This is the same temperature and humidity as the rest of the house. You can see more about that in other videos in this playlist. But what it means is that when the water comes in, it's getting pre-warmed on its way to all the fixtures. And because we've got that big diameter, that time that it takes for the water to make it from the supply where it's coming in from the ground outside, which is definitely leaching any heat that's inside the water and keeping it at that 55 to 60 degree temperature. Once it comes inside, it starts warming up to that 70 degree temperature. And the more water efficient the fixtures we have, the warmer the water is before it even hits the water heater. And that means that if I'm getting a 50 degree temperature rise within this machine, if I can get the water to be a full 70 degrees, 50 degree temperature rise will give me to 120, which again, I do not want because that's way too hot. Now, there's ways to tune this, and of course we have tuned this, and there was a problem initially in this bathroom that I'd like to show you what exactly was happening and the solution, which was very elegant and very interesting. Essentially, we have a low flow faucet here. Faucets are going to be somewhere around like 1/2 gallon a minute to 1 gallon a minute flow. So we were getting that temperature of hot water from this point, which was great. But when we would get into the shower was not that hot. And so I was confused because the water heater that serves this suite, which is 2 sinks here, 1 extra sink in the toilet room, the shower, the bathtub, and the washer, and the utility sink in the laundry room, that is the biggest water heater in our entire house. It's 120 amps at 240 volts, which is basically a 30 kilowatt water heater. That's a lot of power. If it can't do the job, nothing in this house should be able to work. That thing is the biggest piece of equipment electric-wise in the entire house. So it should be able to heat up my shower if it's just the shower running. We weren't doing laundry at the same time or anything like that. So I was a little confused, reached out to Chronomite and we talked through it and we ran a couple tests. So here are those tests. Now a shower and a tub valve have a mixing valve hidden inside of the control of the trim. And since we installed this ourselves, me and my dad, I know exactly where that is and how to get to it. These are all the same brand, which is a high quality brand, and every single one of the valves works differently. It's like a different mechanism for fixing it, which is a little bit of a pain. All you need to know, if you are using point of use water heaters, is that you do not mix any cold in at the valve itself. You want this to literally deliver 100% only hot water when you turn all the way to hot. That way, you're able to just generate the amount of hot water you need and not more than you need, so that when it gets here, it's tempered down. It just gets really complicated when you start talking about multiple fixtures working at the same time trying to generate hot water. So I thought, put all these to all the way hot so that there's no cold mixed in at the valve. But when we activated the showers, all we're getting is maybe high 90s, and high 90s just doesn't do it. So first thing to do is to test that in fact there is nothing but hot being delivered here, and that's a very easy thing to do in this installation because I have a shutoff right before each one of the Chronomite units. So all I have to do is, when this is running on all the way hot, I shut off the water flow to the water heater, and if this completely shuts off just like it is right now, it means that all of the water was coming through the water heater, which is what happened. So now the question is, why are we not getting full power out of the biggest water heater in the entire house? So this says that it's a 1.75 gallon per minute flow water fixture. And so of course you want to know, what is it actually? Because what it says and what it actually is doing are two different things. So let's time it. Measuring cup, 1 quart is what we're going to aim for. We're going to time how long it takes to fill 1 quart and then multiply that by 4 and we'll get our answer. Ready, set, go. Okay.
11:35.
Times 4 is something like 45 seconds. So that means that we're filling a gallon in 45 seconds, which is not 1 3/4 gallons per minute. That's in fact 1.3 gallons per minute instead of 1.75. Why is it doing that? Well, I don't know, but let's figure out how we can fix it. Options are, number 1, we can upsize this shower head. I could put in a second shower head. I could put in 10 shower heads if I wanted to be a maniac, like some of you. I could just take this out, throw it away, and buy one that is less water efficient, which means it's going to be pumping out something like 2.5 gallons per minute, let's say. And that would hit the 1.75 truly. If the problem is with the water pressure, then it's not ever going to perform like what it says on the sticker. But if it's water pressure that's the problem, then let's go downstairs and investigate this further at the actual point where the pressure is created. So here's what's happening when we just turn on the shower at hot, all the way on. You can see that just the first heater has kicked on. And that has to do with the fact that we're not running 1 3/4 gallons per minute, we're running 1.3 gallons per minute. So we're just about to pass up into the second stage where the second heater is going to kick on. You need roughly 1.2 gallons per minute to be able to enter the second stage of heating. In the dark recesses of the crawl space is where the supply water line comes into the house. So this right here is what I want to draw your attention to. If we have too low a pressure, then what we can do is, first of all, find out what the pressure is, because I also have that right there, which is a fin leak detection system, which tells me what the pressure in my lines is. It tells me what the temperature is, pressure, and the flow. I can see that I've got 58-degree water coming in from outside. That's about typical. You'll see 55 to 60 most everywhere in all seasons. And then the 46 PSI is the thing. Now, the pressure comes in at the street higher than that. Let's say like 80 PSI from the city. And we're on city water. I'm not talking about wells right now. So that's a totally different topic, and I don't know anything about that. But when it comes in, I have this, which is called a pressure regulator. It basically reduces the pressure in the line so that it's not at 80, because 80 would be way too much. It'll start breaking things. So what we want to do is adjust this up from 46, because 46 might be a little too low. And maybe if I boost this up, then we can get it to be a little bit stronger, and I could kick into that second gear. So now it looks like I've got 54 PSI. Can you see that? So now, as you can see, we've entered the second stage of heating, and now I've got a much more robust temperature rise. The machine is beautiful, but you can't just put a machine in and expect that it's going to solve all your problems. You have to tune it and make sure that it's installed correctly, because of course the house is a system. So we've learned a lot about water heating. I hope that you have enjoyed this. If you have other things to add about this system or about alternative systems, please do comment below. This is a discussion. If you want to get even deeper into the discussion, please come over to our Patreon membership and join there so that you can help us explore the science of homes on a more regular basis. Grace and I make these videos and edit them ourselves. So please do join that. We have bi-weekly meetups and all kinds of really cool discussions are happening over there, which then inspire things like this. Like and subscribe. Tune in next time.